Everybody, let us see electric braking of DC series motor. In this electric braking, we have to wait and watch many categories of braking system. That braking system are listed below: rheostatic braking, plugging or counter current braking, regenerative braking. Come, let's go with rheostatic braking or dynamic braking. This is very most common braking method in various applications. In series motor, field is proportional to the armature current, always being this field proportional to the armature current. At the beginning of dynamic braking, the field is strong, but gradually weakens because of the reduction of armature current, which may prolong the braking time. To brake the motor faster, the series field can be separated from the armature circuit and excited by a different voltage source. The speed torque characteristics of DC series motor during rheostatic braking. This explanation or similar to rheostatic braking method applied to the DC shunt motor. This is diagram of rheostatic braking or dynamic braking method, and also having graphical representation among the motor braking. Next, let us see plugging. In this method of braking, the connections of the armature are reversed and a variable resistance R is put in series with the armature. The armature is shown in this diagram. To limit the armature current, and external resistance may be required in the armature circuit compared to DC shunt motor. Braking torque of DC series motor falls very rapidly with speed. The speed torque characteristics of a DC series motor for plugging condition is shown in figure. The above characteristics have been constructed in the same manner as that of plugging condition applied to DC shunt motor. Next, we have to see regenerative braking. In this braking method, no load the speed increases, which result decreases in armature current and field flux. The induced EMF cannot be greater than the applied supply voltage or terminal voltage. Hence, regeneration is not possible in a plain DC series motor, since the field current cannot be made greater than the armature current. The regeneration in such a case is achieved by separately exciting the field. Now, DC series motor work as DC shunt. So, this is very typical characteristics of DC braking method. Next, let's go with braking characteristics of three-phase induction motor. A three-phase induction motor has a starter and a rotor. A starter carries a three-phase winding called stator winding, while the rotor carries a short-circuited winding called rotor winding. Only the stator winding is fed from three-phase supply. The rotor winding derives its voltage and power from the externally energized stator winding through electromagnetic induction, and the name in which electrical energy is converted into mechanical energy. It has some advantages. That advantages or it has simple and rough construction. Relatively, it is very cheap. It requires little maintenance. It has high efficiency and reasonable good power factor. Finally, it has self-starting torque. Also having some disadvantages, it is essentially a constant speed motor and its speed cannot be changed easily. Its starting torque is inferior to DC shunt motor. This three-phase induction motor having some synchronous speed, that speed is ns equal to 120 f by p. That mean uh, p is pole, f is frequency always proportional to synchronous speed. Pole is inversely proportional to synchronous speed. So having some torque, that torque called maximum torque is independent of rotor resistance. However, the speed or slip at which maximum torque occurs is determined by the rotor resistance. Hence, by varying rotor resistance, possibly only with slip ring motors, maximum torque can be made to occur at any desired slip or motor speed. So maximum torque varies inversely as standstill reactance, hence it should be kept as small as possible. Maximum torque varies directly as the square of the applied voltage. So it has some effect of change of supply voltage. So torque at any speed is proportional to the square of the applied voltage. The slip at maximum torque is independent of supply voltage. So variation of supply voltage does not alter the synchronous speed also. If changes in supply voltage not only affect the starting torque but also the torque under running condition, from the noted curve, it is clear that if voltage or V decreases, then amplitude of curve also decreases. Ratio may be various torques. Starting torque, maximum torque, full load torque, running torque, slip at maximum torque, starting current, and dull starting or short circuit current, and fraction of normal voltage, slip at full load. These all are names under the ratio of various torque meant by this motor running condition. We picked the various names. So it has some speed torque characteristics. That speed torque characteristics of three-phase induction motor can give the following points may be noted carefully. So slip always having 0, torque always having 0. So torque slip curve starts from the origin. Then normal speed slip is small, so that slip and reactance is negligible as compared to resistance. 2. Hence, torque slip curve is a straight line from 0 slip to a slip that corresponds to full load. Yes, then this type of electrical braking can have to say various clearance about speed and torque system. This system says a different kind of possibility.